Question 3. It says that the straight line 3x is equal to 2y plus 18 intersects at the curve 2x squared minus 23x plus 29 plus 50 is equal to 0 at the points A and B. Given that A lies below the x-axis and that the point P lies on AB such that AP is to PB is equal to 1:2. That's the ratio of this line where P is located. We need to find the coordinates of P. So first we are going to make this equal. As we can see that both of these have a 2y in them. We're just going to move this 2y on one side and 3x minus 18 on one, and we're going to do the same on the other side. Minus 2x squared plus 23x minus 50. Now since both of them have a 2y in there, we can just put them together. So 3x minus 18 is equal to minus 2x squared plus 23x minus 50. We can bring them over to one side. Minus 2x squared plus 23x minus 50 minus 3x plus 18 is equal to 0. We can further still solve this as we have x together and this gives us minus 2x squared minus 20x plus 32, which now we see can be divided by 2 as all of them are divisible by 2. So we simplify it, which gives us minus x squared minus 10x minus 16. And since this has a minus, we can bring it over to the other side. All of them change sign. Which is equal, now we can factorize it. That gives us x is equal to 2 or x is equal to 8. Now we can find our y and our y for this by putting in this 2 into this formula, which gives us minus 6 for this one and 3 for this one. So this one is 2 minus 6, this one is 8, 3. Oh, sorry, this one is supposed to be a minus. This is a plus. This is a plus. Just now there were a few mistakes in my calculation, which I have just corrected, which can now be properly factorized as x minus 2 and x minus 8, which gives us x is equal to 2, x is equal to 8, and we have found the coordinates by putting these x values into this or this, as whichever you wish. I have used this as it is easier. Now moving on to this part of the question, which in which we have to find the coordinates of P. So our line is AP is to PB, which has the ratio of 1:2. Let's ignore that part. So we can just imagine that this is what our line looks like. And since this is for A, this is for B, 2 minus 6, we can assume. And 8, 3, this can be as our B. We can actually assume that P is 1/3 somewhere here, as it is 1:2, which is equal to 3. And now to find P, we are going to, first we see that 2 and 8 have a difference of 6, minus 6 and 3 have a difference of 9. So we're going to write as 6:9, which can further be simplified as to 2:3. But we're still going to use this for one more step, which is 6 square plus 9 square. That gives us 117. You can calculate that using your calculator. And this can also be written as 3 square 13. Since this part is 1/3 of the line, so 1/3 multiplied by 3 under root 13 gives us under root 13. Now we're going to use this simplified form of our ratio for the next step, which is that 2x squared plus 3x squared, so our 2 comes from here and our 3 comes from here, and we square this, and our under root 13 that we have just calculated, we use it and square it as well, which then gives us 4x squared plus 9x squared, and this becomes 13. 13x squared, we add this, gives us 13. Further, x squared is equal to, we divide this, gives us 1. X is equal to plus minus 1. We just assume it as x is equal to 1 because so we can actually just find the coordinate of P by the vector movement, as we already know the coordinates of A and of B, as we have found over here. So it's 2, minus 6, and B is 8. So 8 minus 2 gives us 6, and this is 9. And as we know, it's 1:2, which equals 3 parts. We can just divide both of them by 3, which gives us 2, and this gives us 3. Since we have to find the coordinate of P, we can either minus from this one or minus from B, or add to A. I prefer adding to A. So I'm going to add 2 to this 2, which is 4, and add 3 to minus 6, which gives minus 3. And this is our final coordinate answer for P.